All right, so our notes for today are going to be second law at an angle notes. So guys, listen up. Okay, you might want to copy down this example. It says a 3 kilogram box is pulled across a rough surface by a force of 20 newtons at 30 degrees above the horizontal. If the box is accelerating at 2 meters per second squared to the right, find Fn, that's my normal force, and Ff, that's my force of friction. Okay, we're still going to follow the same steps. This is the same thing we just did previously, like with the elevator or with the notes the other day. But now we just have one extra little step built in here because now we have a force at an angle. So I'll show you how we can navigate that, but we still start in the same place, and that is with a free body diagram. Okay, so I have the axes for my diagram so I can see the x and y directions. I've labeled my positive directions to be upward and to the right. Okay, again, you don't have to label them that way, but that's what I'm going to do for this problem. Next step is to draw the forces on this diagram. So I know this is always a good place to start with the weight. I know that there is force of gravity, there is a weight to this box. Okay, Earth's gravitational field pulls down on it, we get Fg. Okay, I also know that I have this boy pulling it at an angle. And it says that he's using a force of 20 newtons at an angle of 30 degrees above the horizontal. So when I draw it in here, I'm actually drawing it at an angle, and I'm labeling my angle with respect to the horizontal axis, because that's what it says, is 30 degrees above the horizontal. Okay, so I have my force of 20 newtons at 30 degrees above the horizontal. Okay, that force, whenever you pull something at an angle, a portion of that force is going to be, in this case, to the right, and a portion of it is upward because of the way he's pulling it. And so we are going to be finding some components of this force. This 20 Newton force, part of it is in the x direction, part of it is in the y direction, and you'll notice that I labeled those pieces on the picture here. Now, last week when we were talking about these free body diagrams, I mentioned a couple different times that you can't draw the components in your free body diagram on your AP Physics 1 exam, okay, the test in this class or the actual exam. These are the components that I'm talking about. That's why I put them on this picture. I am going to redraw my free body diagram, but when you draw a free body diagram on your test or on the actual AP test, you have to draw it at an angle. Okay, we are going to find the components, but we're not going to put them in our picture. Okay, at least not in the one that's graded. You can draw a second picture out to the side. Okay, and we'll see why you're going to do that in a minute. Other forces to consider. So before I draw the rest of these, it does tell me that this box is accelerating to the right. What that also tells me, though, is that it's not accelerating up or down. Okay, this box is simply moving across the surface with a rightward acceleration, but that means that my vertical forces need to be balanced. And so whenever I go to draw in other forces, I know that I have Fg in a downward direction, but I also know that I'm going to have Fn in an upward direction. And I know that this normal force that I draw in here is going to be adding together with the y component of my angled force to balance an equal Fg. They're going to be equal and opposite, but them together. Now I have two different upward forces and only one downward one. Okay, so we have three different vertical forces now. A component here, Fy, plus Fn, those two together will be equal to Fg. So I did draw this shorter than this for that reason. Okay, again, we don't have any numbers yet, so it won't necessarily matter a lot. I can always adjust my picture later, my diagram later, but you will need to start thinking about how to draw things to scale. Okay, other force that I need to include, it says it's a rough surface. It also asks me to find friction. So I do know that I need to include force of friction, and I know that the force of friction is always going to be opposite the direction of the motion, okay, or desired motion if it's not moving. And so I have my force of friction here, parallel to the surface, so on that horizontal axis, going to the left. So this is what my free body diagram would look like. okay, with all of these forces on it. However, I can't actually solve the problem like this because, as you know, step 2 is to write our net force equations in the x and y directions. And right now, I have some forces that are in the x, FF, and some that are in the y, but I also have this one, and this one is neither in the x or y, it's a little bit in both. And so we are going to have to solve for the components of this 20 Newton force. And to do that, you're going to need to draw a triangle showing the x and y components. It's going to form a right triangle, and this should look kind of familiar because we did this with projectiles. Okay, so we need to solve for the horizontal component, fx, and for the vertical component, xy. And we're not going to put these on our officially graded diagram, but we do need to do it off to the side. You'll do the same thing on your test or your AP exam if you have something like this. Okay, as a reminder, if you're solving for something where you have an angle, and in this case I have the hypotenuse, we're going to be using SOHCAHTOA and some of our trig functions. So for example, if I wanted to solve for this force in the y direction, I'm going to use sine. Okay, it's the SO and SOHCAHTOA. Sine is opposite over hypotenuse. Okay, and I'm using that equation because this is opposite my angle, Fy. So I would say that the sine of 30 degrees equals opposite, Fy, divided by hypotenuse, 20. Okay, and if I want to solve for Fy, I'm going to multiply by 20 on both sides, and it will be equal to 20 times sine 30 degrees. Of course, when you're doing this, please make sure that your calculator is in degree mode. Otherwise, you will get the wrong answer. Okay, this gives us an answer of 10 newtons. Okay, yes. If you are using the Inspire calculator and you want to change it into degree mode, there is a button that says dock, D-O-C. If you push the dock button, there might be more than one way to do this, but this is the way I know. If you push the dock button underneath the on button, this one needs to be reset. It's not loading. Let's see if it can reset real quick. It's turning back on. I think it's documents and settings underneath that, so let me grab a different calculator. You did? Okay. I know if you push dock and then choose option 7, settings and status, and then document settings, that's option 2. The second option there says angle degree. If it doesn't say degree, if it says radians or gradient, you need to change it. But that is where, at least one way that you can change it is right there, and then just select OK. You can tell what mode you're in because next to the battery indicator at the top right-hand corner, it'll either say DEG for degrees, that's what you want, or RAD for radians. Okay, so you do need to make sure that you change that if you aren't already in degrees. All right, so that's how you find the y component. The x component is adjacent to my angle. And so if I think back to that same acronym SOHCAHTOA and I want to find the adjacent side and I have the hypotenuse, I'm going to use cosine. Cosine of my angle 30 degrees equals adjacent over hypotenuse, fx over 20. Multiply by 20. 20 times cosine 30 is 17.32 newtons. These are the components. So when I actually go in and am doing my calculations for my net force in the x direction and my net force in the y direction, I'm using these values. At no point will you use 20 newtons, even though it was the number in the question, because it is neither in the x or y direction. You have to get the components. You just don't draw them on your graded free body diagram. Okay, so I'm going to redraw my diagram now. This would be not the one that's being scored. Okay, but this is how my forces are going to look whenever I'm putting them in the x and y direction. So you can just draw it next to it. Okay, and I have two different upward forces, Fn and Fy, one downward force, Fg. I have one force to the right, the x component of my 20 Newton force, that's Fx, and then Ff, of course, opposite the motion. Okay, so second step after we have our free body diagram is to write out our net force equations in the x and y direction. F net y equals mass times acceleration in the y direction. I already know when I read the question, though, that my F net y is going to be 0. However, this normal force is part of this whole calculation here. It's a vertical force, and the question asks me to find it. Okay, but I know that my F net in the y direction is the sum of my forces, Fn, Fy, and Fg, which is downward, so negative Fg, will equal the mass times acceleration in the y direction. If I can rewrite this like this instead of adding a negative, I can just say subtract. Okay, let's go ahead and see if we can get an equation for the x direction. Okay, F net in the x direction equals ma. In the x direction, I have two forces, Fx and Ff. Ff, of course, in the negative direction based on how I labeled my positive here. So I have plus negative Ff, which again you can rewrite Fx minus Ff equals m times a in the x direction. Okay, so again, remember to keep your x and y directions separate here, and you're only including the forces in the y direction here and only the forces in the x direction here. Again, ultimately, we're going to be solving for Fn and for Ff. Okay, so we're kind of a little bit of the way there already on our way to solving for those things. So let's do Fn first. Okay, again, the question says that we have acceleration to the right, and what that tells me is that my vertical acceleration is 0. Okay, and so, but I'm again going to isolate this, so I'm going to subtract Fy, add Fg, and it gives me this. So Fn equals m times a in the y direction minus Fy plus Fg. Again, Fg is mass times gravitational acceleration. Okay, and so if I plug in, okay, again, this accelerating to the right means that this acceleration is 0. So ma is 0. Fy, we calculated that earlier. That's this y component. It was 10. Mass is 3. It's in the question. Gravity is 10. Again, you're only putting in the magnitudes here. We already accounted for the direction up here. Okay, so if I go ahead and solve for this, I basically have negative 10 plus 30. Okay, which of course gives me 20 newtons. So my normal force is 20 newtons. Okay, now we have to solve for the second piece of this. We're not done yet. We have to also find the force of friction. Okay, that's this one here. So let's go ahead and isolate this variable. We can start by subtracting Fx from both sides, but now we have negative force of friction equals mass times acceleration minus Fx. Of course, we don't want the negative force. We want to just go ahead and multiply through by that negative sign. And now we have force of friction equals negative m times acceleration in the x plus Fx. We can substitute in now. My mass is 3. My acceleration in the x direction is 2 meters per second to the right, so that's 2. And this value for the x component of my force, we found that earlier with the components, was 17.32. So I plug that in, and now I have 11.32 newtons. Again, that's the magnitude of my force of friction. We already accounted for the direction up here. I can see that it's actually in the negative direction. Okay, questions about these calculations? Yes, sir. Yep. Yes, do you have a question? Okay. All right, so again, if you have something at an angle, you will have to get the components, the x and y components, in order to do these calculations. Notice, at no point did I ever plug in 20 newtons, the number in the question. It's not there. And it's not there because it is not in the x or y direction. Instead, we found the components, the y direction and the x direction components, and those are the values that we used in our calculations. If you guys want to open this up on your own screen later on, in case you don't finish before I switch it, this is slide 74 in the notes, and you can go back if you need to make a note, because I am going to move on from this if nobody has any questions. Okay. All right, guys, I'll put it back up in a second. But this is what you're doing for the rest of the class period. I told you it was going to be quick today. I just wanted to do that one example. For the remainder of the class period today, you are working on playlist 3 or potentially working on test corrections in preparation for your retest. All of those things are actually due the same day on Monday. Upcoming due dates that you also have are your friction lab, which is due next Tuesday. And then you have your unit test. Multiple choice test is on the 15th. That is next Wednesday. Free response test is on the 17th. That is next Friday. Your bump assignment deadline's coming up too, but it's not until December 1st. But keep that in the back of your mind as well. Okay, so go ahead and get to work. If you have any questions, please let me know.
This is actually making sense.